Hello students, welcome to Akshara IIT Foundation. So in last class we have discussed and we have done the numericals based on the conceptual questions of centra mass. Today we are going to see exercise, first exercise 1. It is a page number 30. Okay. So here the question is given, the distance of centra mass from the 5 kg mass of the body. Okay. So the diagram is given like this. So here this is the first solution, exercise 1, page number 30. So the diagram is given like this. 5 kg mass of the body is there at all, and at the middle 4 kg mass of the body. That other end 6 kg mass of the body is there. And the distance between the 5 kg and 4 kg is 0.3 meters. And now from the 4 kg to 6 kg it is 0.7 meters. So now we should find out the center of mass of this system of 3 particles. So we know the formula for the center of mass of any system of particles which are distributed along the x-axis. We have seen that xem is equals to mass of the particle and distance of the particle from the origin plus mass of the particle of second particle and the distance from the origin of the particle plus m3 into x3 divided by m1 plus m2 plus m3. Okay. So now we should consider this 5 kg mass of the body at origin. So this is at origin 0, 0 we should consider, and here we should consider this is the x-axis. So the 3 particles are displaced along the x-axis. Now from the origin, the 4 kg mass of the body is at 0.3 meters and 6 kg mass of the body is at so 0.3 plus 0.7, it is at 1.0. So it will be 1.0 meters. Now the coordinates for the 5 kg mass of the body is 0, 0, and for the 4 kg mass of the body it is 0, 3, 0.3, 0, and here it is 1.0, that is 0.1 plus 0.3 plus 0.7, so 1.0. So another coordinate is y coordinate is 0 there. So now we'll see here, this is a 5 kg mass is a m1 mass of the body and 4 kg mass of the body is m2 and 6 kg mass of the body is m3, consider that. Substitute here in the formula, 5 into x1 is here what? x1 comma y1 is 0, 0, x2 comma y2 is 0.3, 0, and x3 comma y3 is 1.0, 0. Okay, now x1, x2, x3 values we have substitute here. So m1 mass is 5 kg and x1 is 0 plus m2 mass is 4 kg and x2 distance is from the origin is 0.3 plus m3 mass, it is 6 into distance from the origin. Distance from the origin is 1. 1.0 means it is 1 only, no? Divided by m1 plus m2 plus m3. So 5 kg, 5 plus 4 plus 6. Simplify it. So it will be 0, 5 into 0, 0 plus it is 4 into 0.3, 1.2 plus 6 divided by, so it is a 15, okay. That is equals to 7.2, 1.2 plus 6 divided by, that is 7.2 divided by 15. Okay, we have to do the simplification. So how can I do that with the 15th? 15 ones are here 0.4 and 8s are. So 0.48 will come there. So therefore, the center of mass Therefore, the center of mass of the 3 particle system is 0.48 meters from the origin. That means from the 5 kg mass of the body. Somewhere here it will be there 0.48 after the 4 kg mass of the body. So here we can observe that this 4 kg plus 6 kg, it is a 10 kg, and 5 kg is the lesser mass of the body. Then the heavier mass of the body is 4 and 6, it is 10 kg. So the center of mass is towards nearer to the heavier mass of the body. So next problem is either here. Second solution. The question is, half of rectangular plate of length small l as shown in the figure is made up of a material of density rho, and other half of density 3 rho, distance of center of mass from the origin. So here the diagram is given like this. See, 2 plates are given, they are connected to each other, and one is a density, it is made up of a material of density rho, this is made up of density rho, and other is made up of density 3 rho, 3 times of the initial density of the material. So now the midpoint, center of mass, it is a regular shaped body, the center of mass will be at the center here, and the origin is there, it is given, and this is a distance is given. Let us consider that the height of the material, first rectangular plate. So we can consider this as C1, and here it is given C2. So this whole rectangular plate of a length L. So the length of this one, it is L. Now half of this length. So half of the length is made up of, half of the length means you can write here L by 2, and this also it will be L by 2. Now if you consider this particle, so consider here it is there on the this point, this O point is at origin. If you consider this is at the origin, so this is x axis and this will be considered y axis. Okay, so 0 you can consider O particle is considered at origin there. So now the first center of mass of the rectangular plate, which is made up of material of density rho. So it is there from the origin at a distance of, this is the distance of the plate, half of the plate, no? So then it will be, it is a regular shape of the body. We know that the regular shape of the body is the center of mass will be coincides with the geometric center. So this will be at a distance of L by 4. So that will be at a distance of L by 4. So we got the distance of the center of mass of the first plate. So now on the x-axis, the coordinate of this will get here. The C1 will be there. C1 coordinates we can write here L by 4 comma 0. L by 4 comma 0. That we can write here x1 comma y1. X1 comma y1. And now for the second particle, second rectangular plate, half of the rectangular plate, it is made up of a material 3 times greater than 3 times of the density of the initial first material, first rectangular plate. Now we have to see this is at what distance. So first one is at from the origin, half of the plate is L by 2, and from there quarter part of the distance, length of the material there. So we can write here L by 2, L by 4 plus L by 4, we can write there 3 L by 4. So we can get here the coordinates of the center mass of the second rectangular plate is 3 L by 4 comma 0. 3 L by 4 comma 0. Okay. So we know that the center of mass, formula for the center of mass of a particles is, which are displaced along the x-axis, we can write here m1 x1 plus m2 x2 divided by m1 plus m2, m1 plus m2. So the coordinates of center of mass of the first plate, we can write here L by 4 comma 0, and here the coordinates of the C2, center of mass of the second plate is, we can write here x2 comma y2, we can write x2 comma y2. Okay. So now if you get the mass of this first plate and mass of the second plate, and we have the distances C1 and C2 are there, so that if you substitute, we will get the answer. So now how to find out the mass of this rectangular plate, which is made up of a density of material rho. So from the density, we will take a mass of the particle. We know that density is nothing but mass per unit volume. Mass per unit volume. So rho is equals to mass per volume. Mass per unit volume. Okay. So then m is equals to, we can write here rho into v. So we can write here m1. m1 is nothing but rho into v, we can write there. Rho into v. So volume of this two plates is 0 because it is half of the length and half of the length. So we will get the volume, and height is here, x is there. So we will get volume will be same for the both the rectangular plates, and the same similarly we will get here m2. m2 is 3 rho v. Density 3 times of density of the second plate, it is 3 rho into v. Okay, now that values if you substitute here, we will get the answer. Now substitute here xem. So xem is equals to, here we can write rho into rho v, mass is rho v for the first particle, and distance from the origin it is L by 4, distance from the origin is L by 4, plus rho 3 rho v, mass of the second particle is 3 rho v, plus 3 rho v into, so distance from the origin, so that is 3L by 4, no? It is 3L by 4, distance is 3L by 4, distance is 3L by 4. Okay. So now xem is equals to whole divided by what you get here, divided by sum of the masses. So mass is rho v plus 3 rho v is the masses of the two rectangular plates there. Okay. So now xem is equals to, so here rho vl, xem is equals to, rho v L divided by 4 plus so 9 rho v L by 4 will get whole divided by, so 4 rho v. Okay. So now xem is equals to, so from 4 rho v is a common in all the terms. So rho v we can take and we can cancel there. See here rho v is there and rho v is there here, and rho v we can cancel them. So we will get here L by 4 plus 9L by 4. We will get here 10L by 4, whole divided by, here 4 is there, no? So we will get there 10L by 16 will get there. So 2 5s are 2 8s are. So therefore we will get xem is equals to 5L by 8. So 5L by 8, that is the answer. So from the origin, the central mass of the two plates which are made up of, one is made up of density rho and other one is made up of density 3 times of the initial density. Then the central mass will be, from the origin it is 5L by 8. So here the correct option is, correct option is option 3. Option 3. It's clear now? Here xem rho v L by 4 plus 3 rho v 3L by 4. this will be the 3L by 4 divided by rho v plus 3 rho v. Then we have to simplify that one. After simplification, we will get here 5L by 8. It's clear, no? Now, next problem, third one. Third question is given. 6 identical particles, each of mass small m, are arranged at the corners of a regular hexagon of side length L. If the mass of one of the particles is doubled, the shift in the center of mass is. Okay. So, initially all the 6 particles, identical particles, are placed hexagon, regular hexagon. If it is a regular hexagon, then the center of mass of the regular hexagon will be coincides with the geometric center. It is at the geometric center. So, after adding one mass extra for any one of the vertices, so then the center of mass will be shifted. Then what is the shift in the center of mass? We should find out there. Okay. So, I will show in the diagram. So, we know that this is a hexagon, no? Regular hexagon means all the sides should be equal. Okay, all the sides should be equal like this. It is almost equal, no? Yes, okay. Now, let us consider this is a M and M. At the vertices of this regular hexagon of side L is given there, means, so each side of the hexagon is L, length of the each side of the hexagon. So, here let us consider this is 2m mass is placed here, and here m mass and m mass. Okay. So, the center of this you consider here, suppose, and this is you placed at the origin, this is placed at the origin. So, this is at origin you consider there, this one is the origin, and here this is the coordinate system. Let us consider it as the y axis, this will be the negative y axis, and here it will be like this, this will be the positive x axis, and it is negative x axis, Now, we should find out the coordinates of each and every particle which are placed at the vertices of the regular hexagon. Okay. So, if this the geometric center of the hexagon is placed at the origin, then we will get it. It will be bisects this side, no? Bisect this side, then we will get this is a L by 2 length. So, this mass will be at a distance L by 2 on the x axis, and this will be minus L by 2. So, we can write here L by 2. So, for this we will get the coordinates L by 2 will get, it is towards the positive x axis. So, L by 2 will get here, and we should find out this one. So, y axis we should find out there. So, this is x and here y, this one we should find out. How can you find out here? So, this is a L, this will be the L, and so this is L by 2. So, this origin means it will be at 0, 0, no? 0, 0, and this particle it is at minus L by 2, will get x coordinates. So, first we will write x coordinates, we will write there, we will write x coordinates, then this will become the diagonal of the hexagon. It will be 2 times of the side, no? We can write here this is this will be L distance. So, we can write here minus L, we can write minus L comma 0, we can write here it is this one is plus L comma 0, coordinates of this particle. In the regular hexagon, the diagonal of the hexagon will be the double the side of the regular hexagon. So, here we can write this is from origin to this particle up to the negative x-axis, we can write minus L comma 0, and towards the positive x-axis means 2m mass of the particle will be L comma, sorry, it may not be 0 because here it is there no in the xy plane, it is there, okay. L comma 0, it is there on the x-axis, so coordinates of this will become y coordinate will be 0, okay, it is correct only. So now for this particle, so this one will be minus L by 2 x coordinate, comma, we should find out here y coordinate. This is a L means if you draw from here, we will get this distance will get here L by 2, no? L by 2 and this L by 2, this is a L. So to find out this distance from here, we will get there root 3 L by 2, no? Root 3 L by 2. Like we should apply here Pythagoras theorem for the rectangular. For right angle triangle, see here, this is a L by 2 distance, and we know this is a L. So to find out this x, suppose let us consider this x there. So L square is equals to x square plus L square by 2 means L square by 4 will come, no? L square by 4. So to find out now x is equal to how much you get there? X is equals to L square minus L square by 4. So we will get here 4L square minus L square by 4. So we will get there 3L square by 4. So therefore x is equal to what happens here? Root 3L by 2. So now for this all the vertices, we will get the y coordinate. So this is along positive x axis. We will get here root 3L by 2. Here we got the coordinate. And for this particle, it is positive half means here L by 2 comma root 3 L by 2 will get there coordinates. Okay. So now for this particle here it is negative. So it is same distance will be there. So it is there on the negative y axis. Here we will get there minus root 3 L by 2. Okay. And for this also we will get there minus root 3 L by 2. It's clear now? Just now we got all the coordinates for all the vertices which are placed at the vertex of the regular hexagon. Now we will write the formula for the XCM. We know that now XCM is equals to so m1 x1 plus m2 x2 plus m3 x3 so on up to m6 x6 divided by m1 plus m2 plus m3 plus so on up to m6. So identical mass of the particles are placed at the vertex of the regular hexagon. Then we know that the center of mass will be coincide with the geometric center, that we know. But here the question is, if any identical particle is added with extra mass, like more m mass is added there, 2m mass, double the any vertex of the mass which is placed at the vertex. So here that is 2m mass it is become, no? Now in this case the center of mass will be changes, position of the center of mass will be changes. We know that if the center of mass, how the position of the center of mass will change? If we remove some mass of the mass from the body, or if we add the mass to the body, then the position of the center of mass will be changes there. Okay, now here if it is added here, then how the center of mass will be shifts, how much distance it will be shifted, that we are going to find out. For that, we will keep this origin of the geometric center of the hexagon at the origin 0, 0, and there we will consider the coordinate system. Okay. Then this m and 2m mass are on the x axis, and remaining 4 masses will be there in the plane. So first quadrant, second quadrant, third quadrant, and fourth quadrant. So there. Okay. And we have found all the coordinates. from this regular hexagon has the length L. Okay. So from that, after finding these all the coordinates, then we should apply the formula. That formula is m1 x1 plus m2 x2 plus m3 x3 plus so on up to m6 x6 divided by m1 plus m2 plus m3 plus so on up to m6. That all the values we should write there now. So they are all are identical mass now except this 2m. Then m into x1. So we'll consider from here, from this negative x-axis, we'll write all the values there. Okay. So m1 minus L1 we can write here. This is a minus L1 distance from the origin, plus m2 is m and x2. x2. So m2 is m only, x2 we can write for this particle. It is minus L by minus L by minus L by 2 plus m into this is a plus L by 2, this will be the plus L by 2, and next 2m plus 2m into L, 2m into L it is there, and plus m into L by 2 and here m into L by 2. So here we can see here these two will be cancelled now. So this mass and this mass is cancelled there. The moment of these two, minus ml by 2, here minus ml by 2 in the same way. So here ml by 2 minus this particle minus ml by 2. These also will be cancelled here. Whole divided by what is the mass of the whole particle there? These are the 5, 1, 2, 3, 4, 5, 5 plus that is 2. So 5 plus 2, 7m. 7m will be there, no? 7m. Now the remaining is what here? The remaining mass is, so I am writing here xcm is equals to, we got here minus ml plus in the numerator only the terms, only minus ml plus 2ml are remained there. So minus ml, 2ml, how much would become there? Divided by total mass of the particles there, total mass of the particles. Okay. So now xcm is equals to, this will become ml, 2ml minus ml, so we will get ml by 7m will get there. So this m and m will be cancelled there, therefore xcm is equals to L by 7, L by 7 will be there. So xcm is equals to L by 7. So that is the shift in the center of mass, L by 7. L by 7. So we got the positive value, it will be shifted towards the positive x-axis, So they given here side of the regular hexagon is L. So now if you put this regular hexagon exactly at the geometric center, then that coordinates will be divides the length, the side L by 2, from that we can retain all the x coordinates, and by using this one, by using the, here this is a right angle triangle form now here, this will be the right angle triangle, this is a right angle triangle. From this triangle we have found there the distance, this distance we have found there, that is that we have considered here, the distance has considered this one from this x. We have found here x. Now if it is x, these all the distances will be equal now. So it is there towards the positive x-axis, root 3 L by 2 will be, and this is at negative x-axis, same distance now from the y-axis there, from the y-axis. After finding all the coordinates, we should substitute that in the formula. Next problem, here next problem is given. Fourth one, a thick straight wire of length pi meters is fixed at its midpoint and then bent into the form of a circle. The shift in its center of mass. Okay. So here a thick straight wire of length pi meters. Pi meters is given there. Length of the thick straight wire. If it is bent into from its midpoint, it has bent into a circular shape, So then the shift in the center of mass, the center of mass will be shifted now. So how much the shift in the center of mass, we should find out there. So we'll see there here. I'll show in the diagram. So this is a thick straight wire of length. Here the length is given. The length of this, it is given there pi meters. This is the length of the center of mass. Now from the midpoint, this is the midpoint now. From the midpoint, it has bent to form a circle. This has bent into the shape of circle there, and it has formed there a circle. So after bending this, it has formed this has formed a circle here. It has formed a circle. So this is a center of mass. Now this will be the radius, no? It will become r radius. This is r. See here now, the total length of the rod, which is the distance of pi l, it has converted into a circle. It is bent into a circular shape. Then the length of the rod. Now here we know that the circumference of a circle, that is, we can write here d, distance. Distance is equals to, distance d is equals to, we can write circumference of a circle is 2 pi r. No, we can write here 2 pi r. What is this? Pi is nothing but the length of the wire, that is the d. So now here we can write this d is nothing but pi meters. Pi we can write there now. Okay. So now from this, pi is equals to 2 pi r. Now this pi and pi will be cancelled. Then r is equal to what happens there? R is equals to 1 by 2. That is nothing but, initially the center of mass will be here at the midpoint, means at pi by 2 distance, pi by 2 meters it was there. Now after bent that's wire into the circle, it will become shifted to the center. Here shifted to the center. Now it has shifted to here, center of the circle. It is shifted to the center of the circle there now. Okay. So then this r we should find out there. R we can find out. So this circumference of a circle is nothing but 2 pi r, and the length of the straight wire is given pi m. So this d is nothing but now pi we can write now. Pi and pi will be cancelled here. R is equals to 1 by 2 will be there. We can write this is nothing but 1 by 2 is nothing but 0.5 meters. So therefore r is equals to 0.5 meters. R is equals to 0.5 meters. Okay. We'll see the next one here. The next question, fifth question is given. It is direct formula only. So for this correct answer, here the answer is given. Answer option 2. Option 2 is the correct answer. So in the previous question, the answer is, for this the answer, here the answer option for this question, option is third option, 3. Option 3 is correct. Okay. This is the answer. Okay, this one. Now see the fifth one. If some mass is removed from a rigid body, then the formula for the position of center of mass of the remaining portion is here M1 R1 are the values for the whole mass, while M2 R2 are the values for the mass of the removed part. Okay, it is a direct formula. So we know that now, suppose from the a mass of body, certain part of mass is removed. So we have seen there from this is a whole mass of the body, consider there. So from this, if this mass has removed there, So now we can write here mass of this is m1, and removed mass we can write here m2. Okay. So now the center of mass, initially the center of mass may be, suppose here it may be here the center of mass. So the center of mass, the position of the center of mass, let us consider it was here there. So now after removing the m2 mass, then the center of mass will be shifted to here, It will be shifted to here. Let us consider it is shifted to bigger mass. Okay, then now the center of mass of the shift, So the formula is given, formula for that XEM is equals to, we can write here, so m1x1 minus m2x2 divided by here m1 minus m2, This we have seen the formula, direct formula it is. So the correct answer is answer option 2. Option 2 is correct one. So they given here instead of x1, x2, they given r1. Okay, here r1 they given. So XEM, the answer we can write here option 2 that is given. No, you can see there here. So m1 r1 bar minus m2 r2 bar divided by m1 minus m2, Okay, that is the answer. So next, sixth one. Next problem. So sixth one is given, a uniform wire is bent into the form of a rectangle of length capital L and width is capital W. The coordinates of its center of mass from the corner R. Okay. So uniform wire is bent into the form of a rectangle of length L and width W. The coordinates of the center of mass. So we know that the coordinates of the center of mass, it is a regular shaped body, so the center of mass will be coincides with the geometric center. Okay, now we'll see there. So sixth solution. A rectangle, a length of rectangular wire, it is bent into a form of rectangular shape. So length of the body is, length of this rectangle is capital L and width is W. Okay, we know that it is the regular shaped body. For the regular shaped body, the center of mass will be coincides with the geometric center. The geometric center will be there here. So now, if these corners are at origin, then where the center of mass will be there. So this is the origin there. Now from here, this center of this rectangular, where it will be situated? It will be L by 2. No, L by 2 distance. So this distance will be L by 2. From here to here, the distance is L by 2. And what is the distance? This distance on the y-axis, the distance we can write here. This distance from here to here, it is W by 2. No, W by width is given W, and the center of mass, center of the geometric center of this rectangle is exactly at the midpoint. So mid of that length, it will be W by 2. So now the coordinate of center of mass we can write here XEM is equals to L by 2 comma W by 2. Okay, that is the center of mass of the rectangle which was bent into a length of L and width of W. So therefore the correct answer is here option 4 is the correct one. Fourth option is right. Okay, clear now? Now we'll see the next question. Seventh question is given here. Two blocks of mass is 10 kg and 20 kg are placed on the x-axis. The first mass is moved on x-axis by a distance of 2 centimeters towards right. the distance should be the second mass to be moved to keep the position of the center of mass unchanged. Position of the center of mass unchanged. Okay. So here two masses, right on the seventh one. Seventh solution. So two masses are kept on the x-axis. Here this is a 10 kg mass of the body is kept here, and at certain distance 20 kg mass of the body is kept here. 20 kg mass of the body. They did not mention here the distance between the two masses. Okay. So we should find out there, and we know that somewhere here towards near here the center of mass will be there. Near to the heavier body the center of mass will be there. Let us consider the center of mass is here. At this point the center of mass is there, that is Cm. Okay. So now if this 10 kg mass is moved towards from here to here, it has moved there. 10 kg mass has came here. 2 centimeters it has moved there. 2 centimeters towards right, near to the center of mass. Near to the center of mass. Then now without changing, without shifting in the center of mass means, if the 10 kg mass has moved towards right, then the 20 kg mass has to be moved towards the left, so that the center of mass will be unchanged. It will not change, it will be there only. There is no shift in the center of mass will be takes place. Otherwise, the shift in the center of mass will be takes place there. Here they given the condition is that the center of mass should not be changed. The position of the center of mass should be there. Then how much the other 20 kg mass of the object has to be moved. So this object has to be moved towards certain, let us consider here x distance, towards left side. Okay, x centimeters you consider there. That we should find out now. So we know that center of mass formula, what can we write here? So this has moved here, no, from here to here and from there to here. So now this distance will not be changed, center of mass will not be changed there, center of mass will not be changed. Okay. So it has moved 2 centimeters and this has moved x meters from this origin. Now here center of mass we can add xcm is equals to xcm m1. So xcm is equals to m1 mass. So m1 x1 plus m2 x2 divided by m1 plus m2. The center of mass does not change, means the center of mass, position of the center of mass we can consider here 0 only, 0, and mass of this body, how much it has distance? Mass of the body, first body is 10 kg and it has moved 20 centimeters, plus mass of the second body is 20 and it is x centimeters it has moved there, left side, towards left, divided by mass of both the bodies, it will be 30, no? It will be 30 kgs, 30 kg. Now if you send this side, if you send other side, it will become 0. Okay. So now we get here this one, 30 you send to the left side, it will become 0. Then 20 plus 20x will get there, 20x is equal to 0. Now here we can write here x 20 is equals to minus 20x. So from here we will get x is equals to minus 1 centimeters. Therefore, x is equals to minus 1 centimeters is the answer. So the correct option is here, option centimeters. Here we got minus, no, minus indicates towards the left, towards negative x-axis. So we can write here the answer is, correct answer is 1 centimeters towards the left. So therefore, correct option is option 1, first option is correct. So this is the correct way. Okay. Next, 8th question. If 3 particles of masses 2 kg, 1 kg and 3 kg are placed at corners of an equilateral triangle of perimeter 6 meter, then distance of center of mass of particles from the 1 kg mass which is at origin, which is at origin is dash approximately, is dash. And they are saying here, assume that 2 kg mass on the x-axis, 2 kg mass on the x-axis there. So 1 kg mass has to be placed at the origin, and 2 kg mass is there on the x-axis, and 3 kg mass in the xy plane should be there. Okay. It is an equilateral triangle. Okay, we'll see now. I'll show you in the diagram. Eighth one, eighth solution. So equilateral triangle. Let us take the equilateral triangle here. This is the equilateral triangle, and the masses. See, 1 kg mass has to be placed on the x-axis. Let us consider this the x-axis, and this will be the y-axis. It is y-axis. So 0, 0, 0, 0. At the origin, now 1 kg mass of the block is mass is placed, and on the x-axis, 2 kg mass of the 2 kg has placed on the x-axis. 2 kg is placed on the x-axis. Okay. 2 kg mass is placed on the x-axis, and the coordinate of that, and this given there, perimeter. Perimeter of the equilateral triangle is 6 meters. The perimeter is nothing but this one. So this side, length of all the sides is a perimeter now. Total length of the sides, of 3 sides, 6 meters is given there. Now each side, how much it will become there? Each side 2 meters, no? This is 2 meters, and this will be the 2 meters. This also will be 2 meters. There also will be 2 meters. Now this mass here, at this mass, 2 kg mass is at a distance of now what on the x-axis, that we can write here 2 meters. 2, 0 we can write now, it is there on the x-axis. X coordinate is 2 and y coordinate is 0. Okay. So now this one here, this 3 kg mass will be here. 3 kg mass of the body is at the vertex. It is in the plane, xy plane. So now for that, the coordinates of this will become, for that the coordinates are, this is a 1 meter, no? 1 meter from the origin. So x coordinate we can write here 1 meter, comma. Now we should find out this one, the height of the triangle. We should find out there. What is the height of the triangle? That we should find out. How can you find out there? By using the Pythagoras theorem. Let us consider this is x distance, x. So we can apply here 2 square, Pythagoras theorem, no? So this is a hypotenuse. 2 square is equals to 1 square plus x square. 1 square plus x square. 1 square plus x square. How much we get here now? So this is 4 is equals to 1 plus x square. Then we'll get it there 3. 3 no is equals to x square. Therefore x is equals to, we'll get here root 3. So x is equals to root 3. Now we got this value as root 3. This is the root 3. It is root 3. This is the root 3. Now this coordinate is root 3. That coordinate is root 3. So 1 meter comma root 3 meters. 1 meter comma root 3 meters. That is the coordinate. This is a 1 meter, no? From this we can find out this height. That height is nothing but the y coordinate of the particle. This is a 1 meter and this will be the y coordinate of that particle, no? There is a root 3 we got there. So total length is 2 meters, means it will be 2, and on the x-axis, so y coordinate will be 0, and this is at and midpoint. This height, the bisector from the vertices, it will be bisects the side equally. So 1 meter and 1 meter will be there. 1 meter and 1 meter. So the x coordinate will become 1 meter, and we should find out this height from the Pythagoras theorem. So it is a 1 meter and that is a 2 meter. Hypotenuse will be the 2 meters. Pythagoras theorem is what there? Hypotenuse square is equals to base square plus height square. No, we'll get here this one. X will get, that is x is equal to root 3 will get there. Okay. So now we got all the coordinates. Now we should find out the center of mass. Center of mass from the 1 kg mass of the body is given there. Center of mass from the 1 kg mass of the body. Center of mass from the 1 kg mass of the body. Okay. So first we will find out the center of mass of this three system of the particles there. Then later we will find out from here. Okay. So we will find out from this origin, from the 1 kg mass of the body there. Okay. So we will see. So up here you note it down. Then we will see in the next remaining solution. We will see in the next class. Okay. Thank you, children.